Hello, thanks for coming for the last Mac 2004 presentation today. My name is Alessandro. We'll be talking about disk latencies and all the storage problems that we might face. The idea here is to just find out if what we're seeing is really true and how can we measure and post to the storage vendor or the storage support how we can translate that to a better solution. So what we're going to see today, I/O overview. We're going to see disk latencies, obviously, consequences on Exchange server, some tools like JetStress and Xperf, key disk events. I mean by, if you see those events on Event Viewer, those are hardware related. Just don't bother about it. Go talk to your hardware guys and just prove it. Store port logging and Xperf. By the way, has anybody used store port logging? Anyway, you have one there? So it's good, right? Very useful. But hopefully we have more people using that after the session. Why store port is very, very important is because store port is the last Microsoft piece of the code before a disk I/O leaves Windows. So we can measure exactly how long did an I/O, a single I/O, took outside Windows. And if it's the most time consuming, you know that's hardware, and you go trace down storage. So basically, an I/O is that, or at least how we transpire an I/O from application side to the hardware layers. So we go through an I/O subsystem, file system, volume manager, partition manager, store port, mini port. When I talk about mini port, it is the actual RAID controller driver or any type of disk driver that you have. And then you have the actual hardware subsystem. But basically, an I/O is just a memory transfer. So if you're talking about Windows, it's just an application created a memory pointer that is going to be transferred to another memory pointer that will translate somehow on I/O. It is packet-driven. Basically, each I/O is independent. So each I/O has its own features, size, priority, and they do not mingle with each other. So that's the point. When we are doing latency, we just see the average latency. We go to Perfmon and see average disk seconds per head or write. Actually, we're doing just an average of all the I/Os that were collected during the interval that Perfmon. So JetStress, for instance, by default is 15 seconds. So the 15 seconds interval, it goes and traces out I/O that went down from that 15 seconds and takes an average. So it's an average of the second average, because the smallest time frame on Perfmon will be a second. That's why every time you see a per second counter, be very aware it's going to be an average. So if your interval is longer than 1 second, you have to account for that. You take an average of the average. If I translate to drivers on Windows, that's what we get. Right? The application could be anything. In our case, good old Exchange. And then we talk to the NTFS, we talk to disk. The MIO is going to be the drive that will mount a label. Actually, we'll mount a drive label. And the partition manager will actually mount the physical disk. Right? So if I open Perfmon and open logical disk counters, I'm looking at the MIO. If I open physical counters, I'm looking at partition manager. And look, store port is right down there. So my next point is we need to go there and check. Doesn't mean that what we see on physical disk counters on Perfmon is meaningless. Actually, it helps a lot. But it does not tell the whole story. Because there are two main points of latency. One is the average latency that we all care, and we have all our settings, 20 milliseconds average for read, 10 milliseconds for transaction logs on write, and we have spikes, 100 millisecond spikes, 200 millisecond spikes. But the average will not tell me all the spikes. It will tell me an average of spikes. But when you see an exchange event or any other application event saying that a single I/O took too long to complete, that's our delay. That's our stall I/O. An exchange after 60 seconds, if I don't have anything, it will throw me an ESC warning saying, whoa, this I/O completed successfully, but it took 60 seconds to write 32K, or took 60 seconds to read 32K. That's awfully a long time for a 32K packet, right? So basically, latency, it's time, right? It's delay. No more, no less. Of course, if you're talking to IT, that's what we care about, right? This latency, the amount of time it took an I/O to complete. As I mentioned, where and how you measure is very, very important. Particular disk latency has many points that can influence. Basically, the size of the I/O. So Exchange could create a size of 32K, which is our page size. Could create a I/O size of 256K. Could be BDM, background maintenance normally creates those size I/O. Transaction logs could go from 32K to 1 meg. Depends on how fast we want to flush a transaction or to commit a transaction. So Exchange will do all that. Então, every single I/O will get a different response on my subsystem. Priority, an I/O could be a normal priority, a high priority, or a low priority. If I have too many low priority I/Os, my latency is going to be up, even though those are low priority I/Os that will not cause any problems. But the latency is just measured from when the queue is empty or not. And if we have a low priority I/O or too many low priority I/O, the queue is always going to be full or with something to process. Another thing that we sometimes forget about is location. Where I'm doing my I/O matters. So that's why on JetStress we do the 80% full disk. Because as we create a disk or as we touch different parts of the disk, the latency will be different. Because it's a mechanical thing and we need to go up and down. And we have what they call short strokes or long strokes. And so that's why it's important on JetStress to get your full volume. Because if the same type of I/O doing on the outer layers of the disk is going to be faster than the inner layers. Basically, that's a very small test that I did. I just create 2 partitions. Those are exactly the same disks, same form factor, same vendor, same firmware, same everything, and the same test. But the first one was a short stroke, or I just create a small partition right at the beginning of the disk. The second disk is right at the end of the disk, just a 100 gigabyte partition. And I just ran JetStress just for the fun of it. If you look, the difference on I/O, one barely passed, and the other one just failed. But that's not the point. My point is, just by changing where my I/O is located, I have different latency for the same hardware. Exactly the same hardware. So we have 5 milliseconds. On an Exchange, that could be the difference between everything okay and support calls in the middle of the night. Another illustration is, here is just a summary of 2 seconds of JetStress. So you see the difference between the time that the I/O completed, the size of the I/O, and where the I/O touched it. So we're going to go demonstrate that on live here on how to look at it. But just as an example, just a small just stress or any small exchange will have a very different I/O profile every single second. And we're going to be doing that throughout the life of exchange. Then there's caching, right? Caching happens every single layer and every single time. You have caching on exchange, you have caching on file system, you have caching on the controllers, you have caching everywhere. Caching helps you because caching will level out burst of I/Os. Because that's one of the most important features of caching is that when I have that peak I/O that I know that my hardware will not handle that, but caching will do lazy writes afterwards. So having good caching is very important for good performance and to even out those peak latencies, right? And another important thing or consequence about caching is that a file I/O does not necessarily mean a disk I/O. So when I get a file, not necessarily I need to go to the disk to get a file. I can go to the cache. That happens on a file system. Have you ever had the issue where my first time I copy a large file is very slow, but the second time is very fast? Just like, whoa, yeah, file system cache on Windows. I just copied that file, it's on cache. The second time I'm copying exactly the same file. Very fast. Actually, a lot of support calls on that I have. Because, my second time, my controller must be bad because first time is bad, the second time is fast. I want the second time all the time. No, when I get, right? Because you need to read the first you need to read the file. So now that we see how, have an idea how an I/O is created, we can go to our good old exchange. Very, very simple schematics on how exchange creates I/O just on the database. I know that I'm missing search, I'm missing indexing, I'm missing a lot of things, but if you're doing just stress, you care about database, ESC. So ESC basically, it's going to be how fast can you move pages in and out. That's basically what we need to know. Why? Because every time I'm a client, an Outlook client, OWA client, any type of client wants to get a page out of Exchange, I will go to the store cache. And once I touch that page is dirtied. I make a copy of that page, and that page is locked. Locked means nobody can touch that page, even the client. The client needs to wait something to happen. So that's the first point. Then the page number is just move it. Just the page number, not the transaction, just the page number, move it to the version store. Or if you go to Perfmon, it's going to call version buckets. So every time a page is touched, that page number is moved to the version store. Do you know why do we have version store? What's the function of a version store or version buckets? Keep track and roll back. So if something happens and I need to roll back, because every time a database crashes or I cannot complete a transaction, I need to roll back. I need to go to the previous state. And so the version store will keep that tracking till that transaction is completely safe. Then I will drop the version store. Exchange 2003, who is old enough to, or 2000 or 55, was very common to see event 623, which is version buckets is full. Normally, backup operations. Because one of the key functions of key characteristics of version store is that the longest running transaction will just go out when it completes. And everything that went after will have to wait that the longest completes. So that's why we sometimes we have that 623 because the version buckets was getting full, because there was one single transaction that never completed, and that was filling up the version bucket store. Normally it was a backup that just froze the database, or snapshots on that sometimes creates that. But on 64-bit, we rarely see that because the version store size is so big. On Exchange 2003, 2000, it was a matter of 100 megabytes or something like that. So when I touch the page, I do what I have to do with the page, so I have a transaction. The whole transaction is moved to the transaction buffer log. So it's just another buffer, another cache inside the store, on memory, that I will put that transaction aside. After that, depending on the type of the transaction, or if the transaction buffer is full, I'm going to save the transaction on the transaction log file. So that's basically the first time I went to the disk, right? And I know that I need the 10 millisecond delay or less on this particular operation, because I don't want my buffer to get full. Because if my transaction buffer gets full and I cannot flush, what happens? All the pages that I'm touching, because here I'm just showing one request, right? But it's happening a lot of requests every time. And how many requests can we have on the Exchange 2007, 2010, 2013? The RPC request queue, what's the biggest? What? Nope. Less? 500. Have you heard of the 500? But if you look at the guidelines, if I'm over 70, I'm already having problems with my Exchange, because I'm filling up requests much faster than I can get rid of the transactions. That could be disk, or that could be something else. But disk is a very big culprit here, because normally you see a lot of stalls that I cannot flush my transactions log fast enough. But after I save my transaction log, so I can unlock the page, and then the Outlook client or the OWA client will have the page, and he will be able to do whatever he wants with that page. That happens in a matter of milliseconds, right? So much faster than I can talk. And after that, after some time, there is a lazy writer function on the ADB that will just sync the pages. We'll flush that page. Actually, here is a very important concept. There are two types. We have a flush the page, which is basically syncing the page. The page is still in memory, but I just replicate the content of that page to disk. So if anything happens, the EDB file is already up to date. Or there is a purge that is, I'm taking out the page out of memory. I'm just getting rid of the page out of memory. That could be just because my DB cache is going down, or it's full and I need to replace. And that brings us to two main points on Exchange. One, on logs, we have log records stalls per second, which is just how I need to flush a transaction log, but I cannot. The disk is full, or so I have a stall. That happens all the time because the transaction log is very small. But on a database, that can never happen. So if you see a database stall, for sure you have disk problems. Database stalls per second. Don't miss up, there is a very common misconception on database faults per second, which happens all the time. But a stall per second never happens. Or if it does, you just blame storage because it is. Just a brief summary. Again, just everything happens in memory, right? So what I said is just listed that. So when you get the slides, just follow through that. For an application, latency is everything, right? Have you ever heard that latency is everything and throughput is nothing? I can have all the throughput in the world, but if I cannot write fast enough, Exchange will suffer. That's the bottom line. So when the storage guys, I have X megabits per second of throughput, this doesn't matter. How fast can I write? How fast can I retrieve information from the storage? That's what we care. And the more complex the storage, the harder it is to identify where I have the problem. That's why we are going to JBots. Because have you seen how many IOPS does an exchange use today? It's just free, almost, right? It's 0.10 per mailbox. 0.10 IOPS per mailbox. You need like 100 mailbox to get 10 IOPS. Just, okay. That's 10 IOPS. Can you get 10 IOPS where basically anything can give you 10 IOPS on 20 milliseconds, right? But can you get 10 IOPS with a 100 gigabyte mailbox? That's a good question, right? You cannot get 100 gigabyte mailbox on an SSD or on a 10K drive. Or you could, but it will be one mailbox per drive. Not the best cost efficient, right? Stalls. I mentioned stalls before. It's just an idea to make room for transactions to go up and down. We need to be aware of those. Log records stalls per second and database stalls. Log record stalls per second, 100, it's an average number. It's a peak number. So we don't want to see constantly my log records stalls per second go over 100. Because that indicates that even though there are no client problems right now, but if I just push a little bit harder, my exchange might start getting those pesky pop-ups, connection. Because when I go back to my RPC requests, when an RPC request gets to exchange, I timestamp it. When it goes back and I complete all the cycle, I timestamp again. And there where I get my RPC average latency. So the longer it takes that cycle, my RPC average latency will go up. And that's where clients will complain. Because I just click something and nothing's happening. So just a little, so what I want to do with, I have a couple of demos, but every time I stop for demos, if you have questions or any concerns, just raise your hands. See? Yep. So basically, good old performance monitor. That was a performance monitor from Jet Stress. So what you can see from Jet Stress here, I just got disk average reads and the I/O database reads per second. So basically, I'm measuring almost the same thing because Exchange is the only thing touching that disk. I can see that it's basically the same. So just by looking performance monitor, I can tell that, okay, all my latency during this capture is coming from the physical layer or from the physical disk, from the partition manager layer, right? If you are into it, database, there are a lot of database counters. Cache size, very important one. We can see a lot of things here. But from a Jet Stress perspective, we are just getting into the reads average latency. And we can see version buckets, we can see stalls. But version buckets for Jet Stress won't matter much because it's just a synthetic transaction, so we won't fill up version buckets. So for Jet Stress, that won't matter. So far, so good. I know that's very dry right at the beginning, but it's an important concept that we need to get for the previous slides. All right. We can Continue. Okay, on perf mode, like I mentioned before, for disk, we have physical disk and logical disk. They are measured on different stages. So that's what we need to understand. And also, every time we see a performance monitor counter, doesn't matter if it's a physical disk, a memory, we need to understand what type of counter. It is a cumulative counter, like network packet errors. It's cumulative. When I start the server, it starts counting. So if I see network errors, do I have network errors? Only if it's going up during the time that you had the problem, right? Average per second, it will matter what's your interval size. So the longer the interval size, the more skewed the data will be, because we'll be having an average of the average in that second. When I'm looking at perf mode, I'm looking in all the time that is spent on the hardware layers, the I/O is spent on the hardware layers, and on the store port. So that's a very good information right there. Hardware layers and store port when I'm looking at performance monitor, physical disk. So what that means? It means that I'm not taking out all the Windows components yet. And also, antivirus, when you're scanning for file, they hook up on that level, on the partition managed level. So remember when you do file exclusion, right? But you can do driver exclusion on antivirus. So where they hook up, where they insert the filter drivers is in that layer. So if you see a high latency there, it does not necessarily mean that the hardware has a problem. It could be a filter driver just installing your I/O. Another important concept is queue. Have you ever had the problem where you have an HBA adapter and you have to go and increase the queue length size? Normally from 32 to 64, right? Why is that? There's a long answer for that. Yeah, go ahead.
From what I understand, it was because it was queuing up and probably the I/O and HBA, so as not to oversaturate the switch potential. It was kind of like a very conservative way. Well, that's like one default, but it's a way to restrict I/O.
Yes, we do a lot of throttling on queue depth. The easy way to explain queue depth is how many I/O packets in parallel can I accept? 32, 64, 128. So when I reach that point, my upper layers detect that and stop sending I/O. So sometimes you need to increase the queue depth. Sometimes I'm sending too many I/O packets at the same time, so I need to decrease that. So it's a fine-tuning. You need to talk to your hardware vendor to actually make sure that that setting is okay and supported, right? Because each one will have a different setting for different reasons, right? But basically, if I hit that, I/O can stop. And how I see that, my current disk queue length is going to continue go up, but my disk bytes per second, or my transfers per second, by the way, better, my transfers per second, which is my IOPS, are going to go to 0. So I'm still receiving I/O, but I'm not processing anything. So that could be an indication that my HBA has reached the peak of my queue depth. So if you increase that, most likely you will have a better throughput or better latency, because all those disk queue that are accumulated will increase your latency. Because every time I go there, I just timestamp, and when it goes out, I timestamp again. So it's basically math. All right? I touch a little bit about physical counters, right? top two ones, latencies, the ones that we use for exchange all the time, right? Idle time, sometimes we don't look at idle time, but idle time just means how busy my disk was or was not, right? What's the idle time for my disk? So if I have high latency, but my idle time is like 60%, okay, my disk still has time to accept I/O. Because idle time is calculated only when my disk queue is 0. Every time my disk queue drops to 0, I go to 100% idle, right? And then I just average that time. So that's an important measure just to see if your disk per se is idle all the time or not. Transfers per second is basically your IOPS, pure IOPS. You can divide in writes or reads per second if you want that average. But if you want to go to the calculator, I need 55 IOPS or 60 IOPS, disk transfers per second. You add read and writes. Bytes per second, the size of I/O. And another one that we normally don't look at, but I have seen a lot of problems sometimes, is split I/O. Does anybody know what does split I/O actually mean or indicate on the file system or on the storage? Fragmentation, yes. So what happens when I send a read I/O to a file, and the file has 100 extents? How many IOPS I'm going to send to the controller? What? 100? Yes. So if you see a very high split I/O per second, actually your disk transfers per second are not physically correspondent on the storage. You have your disk transfers per second plus your split I/O. Just a quick thing, defragmentation or fragmentation is not only a physical thing. Actually is a file system thing as well. So you can have, and it's actually more likely to have an NTFS fragmentation than a physical, the one that we normally associate fragmentation with. Oh, I have all my sectors scattered for that file. That happens too, but most likely it's just a file system fragmentation. Your MFT is fragmented, and you have, when you save a file or you extend a file, write to a file, I create extents. And I need to just put that on my MFT. That gets fragmented. And that will also indicate split I/O. There's a good blog from Mike Lagasse on Exchange 2007 that explains right this. And it was not a physical disk. It was a NTFS problem. That's a very important thing. When people are complaining, the storage guys are complaining, look, I'm receiving 2,000 IOs. And you go to perf, no, I'm just doing 500. But if you have this split I/O, actually, or any other application, because send storage, right? Exchange, I haven't seen Exchange done that. But if you have shared storage, other applications can, mainly file servers. If you have a file server sharing storage with Exchange, most likely you have that. So let's take a look on performance disk counters. Any counters that you're interested that I didn't put there? I can. No? I know. So basically, I get just for disk 1, which is the one. Never look average disk queue length. Never trust that. Current disk queue length is the good one. Latency, right. Transfers per second. Split I/O. I always like to scale things. So you see that my average disk queue length is 0, or peaks of 4. But that's a single disk, single spindle. So I have to just take a look, which this one we don't want, right? We want current. Yeah. No, we don't want that. That's a bad one. So we want the current disk length. That's my read latency. The bad read latency here. Right? So when we're looking at this, first look at your whole interval, 10:47 to 10:56, 8 minutes. But what was my capture interval? That's what I'm interested here. If you don't know, you can try to zoom in and try to zoom in a little bit more. I would say that my interval here is 1 second. Right? You see right here in the bottom, 10, 12. So that's a very important piece of information when you're analyzing. Let me unzoom. And we always look for trends. So I see my read latency. My write latency is very, very small. We do have some spikes here, but it's just because of the scale here, but the maximum here is very negligible. So I would say writing on this disk was fast, reading, not so much. And that happens. The good thing about jet stress is that when you change vendors, you could jet stress that disk and see how it behaves on reads. And we'll reveal some differences. But what happens is that every disk vendor has a way to treat I/O. It's not good or bad, it's just the way they create the firmware. So sometimes that can have that type of effect on latencies. Here you see your IOPS. I'm throwing 65. That's a lot. This was a nearline SAS disk. How many IOPS do I normally have on a nearline SAS? Oh? Nearline SAS. Nearline SAS is 72. 75 IOPS. Do you know the calculator, how much the calculator assumes for that? What? 65? Have you seen the calculator where you have the table for that? Yeah, 55, right? So for those, so if you do a unhide and go to tables it is, and we have here. So those are what the calculator assumes for those type of, right? Just an assumption, right? It can do more, it can do less. It depends on vendor, but that's an average, right? That's why we just stress every time to make sure that what we're getting matches what we assume. And look at the sequential disk I/O 300, right? Because it's sequential. On a JBOD, on a DES, yes, don't worry about sequential reads. But on a virtualized storage, yes, do worry about sequential reads. Virtualized storage does not treat sequential reads as sequential reads. Let me just put it that way. So we will have issues with read latencies on issues. I mean, you're going to have unexpected results sometimes when we're doing sequential reads on a virtualized storage, because there are not a mapping between spindles and what we have. Ready? Well, my clock didn't start here. Do you know how many minutes do we have? Yeah, yeah, we are the last ones, so who cares? Yeah, yeah, we just see, oh, well, we're still there, yeah. So jet stress. So who actually went to Neil Johnson's session, right? Jet stress, validation, validation, validation. Run every time. Got a new hardware? Jet stress. Got a new disk? Jet stress. But jet stress is validation, is not benchmarking. You know, we have several cases where customers say, well, I run jet stress on this disk and gave me X, and that disk gave me Y. But both passed. But I don't want disk Y, and yes, because it's faster. Maybe, right? So don't treat jet stress as a benchmarking tool, because we cannot control how jet stress actually creates I/O. And that's the whole point, right? Another thing that I've seen a lot, and probably Neil Johnson has more experience than I, is that if you don't mimic exactly what you have on your test, the test is not valid, right? If you are, yes? Never. Well, normally, normally you got that server before production. You were in a project, all right. But you don't want to run jet stress after you got that in production. No, it won't do you any good. If you don't have a spare server to test, you just have to trust your vendor. Trust your vendor that they have a replaceable part, right? So because when you ask for a nearline SAS 72, you get what you get. You get from your vendor, but what the vendor got, it's not. We cannot track that. You can have 4 or 5 different vendors, and they are within the specs. Because these vendors will not tell you the latency, because they cannot measure, because it's something that is application level aware. What they will tell you is the seek time. Right? So what's my seek time for read and writes? So what you can do is, when you get that, go to the vendor's website and compare the specs from what you had previously. Right? So that's the best alternative, because you don't want to jet stress just because of a disk, because you already supposedly you already tested that before, right? I'm just changing the disk on the JBot, and that's the idea. We assume that they are comparable. The only thing that I see is that if you are just capping, right? You saw the IOPS for nearline SAS 55 that the storage calculator assumes, which is way below that what was getting there, right? But if you just capping that, you jet stress, you're getting 18, 19 milliseconds read, and you're just stopping that disk. When you change the disk, you may have a failure jet stress if you run that, because it's a little bit different on the SKU. But that doesn't mean that your exchange will suffer, because we need to match all those exchange counters with the disk counters, because it could be something else. It could be, so long story short, I don't think it's worth it doing that. Yes?
Can I just add something for the lady in that previously I was doing a jet stress with HP JBot, and we had disk failures during the jet stress.
Yes.
We got spare disks, and the firmware version was different to the ones we tested with.
Mm-hmm.
The problem is HP had dodgy firmware for the disk called Seagate.
Yes.
So we had HP give us totally new disks, and the new disks had a different jet stress profile than the previous ones. So it's probably quite important to look at the disks.
Yeah.
It's just, yeah, and they're not. Yeah.
Yeah, so when you run jet stress, firmware, hardware, Firmware is very important on this because that's what controls how the disk operates.
But the problem is, though, is that you do, it's exactly what you're saying, you do your jet stress and you prove everything. Then you go into production and the guys that replace the disk when you lose a disk don't look at the disk and see if it's the same as the one they're taking out. And all you need is bad firmware. And
Yes.
one disk which may have 100 users on, they're going to have problems, whereas other people...
Oh, other people know.
And,
But that's...
and you can't, there's nothing you can do about it.
Hello.
Hello.
Does everyone know who I am? Probably not. No. So my name's Neil Johnson. I own jet stress guidance for the world, really, for people that use it. So there are a couple of things to be aware of with jet stress. This scenario is not what it's meant for, so it doesn't cater for it. So, you know, the concept of a single JBOD spindle failure, we have to trust that the vendor is going to supply back a spindle similar to the one you issued. There are cases where they don't. But JBOD's not the unique scenario for that. Imagine you're in a RAID array and you do the same thing. Same thing happens. It still sucks from a perf perspective. You just don't know which spindle causes it, and it's much harder to troubleshoot. And jet stress is not going to help you with that, right? There are other ways that you can do that, but you're in a bit of a world of pain at that point. It also comes back to having good lab equipment as well. So if you suspect that scenario, so you know things have been running happily, you've done your jet stress testing, everything's great, you've gone into production, and then a few months down the line when you've replaced a few of these disks, you're starting to notice latency creeping up or behavior isn't what you expect. That's the time to head back into the lab and chasing down those firmware versions, or maybe talking to the storage vendor. In JBOD world, that microcontroller code, the stuff around, people don't realize there's a lot of code that lives on the disk, there's stuff that lives in the controller, and sometimes they don't play well together, and sometimes they do. And there are many cases in the service where, if you think about this, the service runs, Office 365 runs exactly the scenario with JBOD. They jet stress test for burn-in, but they don't jet stress test after that point. And they've had scenarios where they've run into exactly this issue. And unfortunately, there's nothing we can do with jet stress to fix that. If you run jet stress, and you can run jet stress, I'm going to regret saying this, I know, but you can run jet stress on a production Exchange server. The way to do that is to shut down Exchange and make sure you use the same versions of EasyDLL in your jet stress test, so you can do it. You've still got to shut Exchange down, and it's unsupported. So it's not something that we want you to do. And jet stress is just the wrong tool to deal with that, and there isn't really a good way to deal with it.
Yeah.
Yeah, exactly. And so if you knew the event that had caused it, the disk change, or let's say for example, I don't know, the server team decide we're going to do firmware updates on stuff, and then you get some weird performance, then that's back into the lab, and all right, let's see if we can use jet stress to deal with that.
Yeah,
it's the wrong tool for the job for that case. You're troubleshooting really at that point.
Yeah, more likely firmware updates will cause that too. So actually, I'm chasing down one of that right now. But I cannot talk about that. Well, not now because I'm just support. I just detect the problem and just move along. Just call the guys that do the firmware and just like, look, there's something strange here. All right, move along. So another thing is, on the jet stress, we have achieve and total IOPS. We need to understand the difference between those two. Achieve IOPS is just DB IOPS, so just read and writes that the database did during the jet stress time, so it does not account for logs or BDM. But we need to look at the total IOPS also in the jet stress report, mainly if you're doing shared storage, because of that effect that BDM does, because BDM does a lot of sequential reads, and that does not play well with virtualized storage. So every time you have virtualized storage, you may run into problems and run jet stress with background maintenance. And that's because that's the point. We don't want to disable BDM, right? We want to run jet stress with BDM. It's just that you're going to see a high read latency with that. Another great point is JSTRS is not aware of any advanced storage technologies. So if you have those fancy storage that does tiering, theme provisioning, whatever they come up with, JSTRS is not aware of that. It just treats everything as a single volume, right? Mainly with tiering storage, if you're doing tiered storage in JSTRS, just don't even bother. Because you're going just to get awful results. We got JSTRS results that are just amazingly bad. Not because the storage was bad, but because the test does not play well. And it's awfully bad anyways, the results. So we need to be aware if you have those type of storage. And we can talk about that later, because that's a big topic. This is just a couple of seconds of JSTRS, so you see that touches the disk all the way. 80%, that's a 80% full disk, so you see that the top line is not used. And you see all the disk seek time, so that's how JSTRS stress disks, right? So that's why we discover problems, yes? This is XPerf. We're going to see that tool now. XPerf is a really powerful tool. Just 5 minutes of data got me 2 gigs. All right? 5 minutes of capture is 2 gigs worth of data. So it's quite a lot, right? But it captures every single thing. And I didn't capture process or anything, just disk and file I/O. But just to show you, when we run JSTRS, we run 80% of the time of my disk. So I'm touching all the offsets on that. I'm doing reads or doing writes, and if you run a lot, you actually know what the pattern is. So you see in the middle is more the random reads and writes. On the top and bottom is either BDM and log writes, because it's there. So it's kind of interesting. But that just to show you how JSTRS stress the disk. And all those vertical lines are seek times, so disk seeks. So the disk went from here, oh, I need to go there, I need to go back. And so that's how JSTRS discovers problems with disks, one of the points. And that's why when people come, have you ever heard from the storage guy, but we ran I/O meter and it was fine? I/O meter does not do that. I/O meter is either sequential or random, but it does not create the same workload type that JSTRS does that will be exchanged. And that's what we're looking for. Much easier to run JSTRS than to tug of the threads and try to get I/O meter to do that. And it's basically going to do the same thing, so we already have the tool for that. And it's the only tool that we can validate the exchange on storage anyways. JSTRS report, just a quick peek. So here I have a fail test, single disk, went 23 average, it failed because of the read average. But good things here. Achieved transactional IOPS, 91. So 91 dB IOPS, right? So read and writes from the DBs. This is, again, a nearline says. So technically, I'm pushing more than nearline says is actually capable of giving me within the 20 milliseconds, right? There's nothing wrong with the disk. It's just the disk is not able to cope with the amount of IOPS within the 20 milliseconds that we are expecting, right? Total I/O performance. So the good thing here is this 91957 will be the sum of I/O database reads and database writes. So if you just sum those two, is your achieved IOPS. If you have many databases, just do that. Yes? Question? Okay. When you do total, then we have here I/O reads. Normally you're adding your BDM reads. So that's your total IOPS there. Important just to realize what everything means. Memory, very low usage memory from JetStress, because we don't want to be using caching. When using JetStress, we want to touch the storage all the way. So that's why we don't have that much memory. But when you're testing, you want the full server, right? The server the way it is. Any question about the... All right, dealing with complexity. So complexity storage or any type of complexity. Complexity leads to pain, pain leads to suffering, suffering leads to long support calls with somebody that is not willing to help you sometimes, right? So every time that you can avoid complexity, avoid those fancy storage with Exchange. I know that is not possible 100% of the time because customers, they have different ideas or they already have different agendas, right? And then we are sometimes stuck with something that we never planned, and we have to actually make Exchange work on something that's already in place, right? But the more complex it is, it takes more time to design, to validate, and to solve. So when you have a problem, it takes a long time to solve. And if it's a firmware problem to run a high-end storage, it can take months till you get a response. Clearly. If you're using JBot, you just ask for another disk. And most likely you have other copies, right? So that's a difference there. It's not that it's not going to work. If it's well-sized and well-tested, any type of storage will work with Exchange. It's just that does not make a lot of sense to spend all that time and money to make sure that it's going to run when you have an alternative that is cheaper and most of the time faster, right? If you put a DAS enclosed and external storage, let's say 60 spindles, those 60 spindles can do more IOPS than basically any SAN that you can hook up for Exchange. I mean, for Exchange, not for other things, right? Other workloads will have different, but the amount of spindles that you need just because we want higher capacity and one larger mailbox, that leads you to put more spindles. And that leads you to add those 70, if our nearline says 70 IOPS per spindle. So when you see, you actually get a good amount of IOPS there for a fraction of the price. So, JetStress and advanced storage. We need to, if you encounter advanced storage, you need to make sure what kind of features those storage have. It's theme provisioning, tier storage. Has anybody played with theme provisioning or storage or and all the guys there? Any happy conclusions or just so? Well, as I said, you need to test, right? Theme provisioning is something that it's okay. It just presents a volume that you say that is 2 terabytes, but actually you have just a fraction of the physical storage, and then you increment through time. But how do you JetStress that, right? So one point is at least JetStress for IOPS. Make sure that you know how many IOPS you actually need from the get-go and JetStress that. If you have all the spindles available, I would just JetStress as a normal, from the final configuration. Make sure that everything is okay, and then you just present the theme provision and you just do the IOPS JetStress theme provision. It's not the best solutions, but at least it's something that works. And one thing, a pass is only valid if maybe it's the provision. Must meet the IOPS all the time. Thin provision sometimes is associated with data movement, tiered storage. So if you have data movement with thin, you're not only thin provisioning, you have tiered storage. So we have all other vendors, and that's another point. Continuing with thin provisioning, I've seen a lot of issues with thin provisioning and unmapping. Unmap is the command when we delete a file on Windows that tells the storage to actually clear the blocks on the back end, and then you actually have the free space. Because if you delete a file on NTFS, it will delete the file just logically, right? MFT is going to be cleared for that particular offset. You see the free space on NTFS, on Windows Explorer, fine. But the storage guys on the back end say, well, nope, it's still not purged because we need these unmaps. Windows 2012, Windows 2008 R2, they do unmaps by default. But not every storage vendor understands unmap. Sometimes they can use another type of command. So you have to consult with the storage vendor if they need an agent to run on Windows to actually free up space on the back end. Because I delete the file, well, the file is out of NTFS, but you still have a space there. So why that could cause a problem for thin provisioning? Because actually you are using more than you actually think. So thin provisioning, if you don't have a very strong monitoring system and you understand how long does it take to actually expand the storage when you need, not when you need to know before you need, right? So, my transaction logs are getting big, and I don't have enough space. It's going to go down. And how long does it take to actually expand that storage? A week, I don't know, right? So are you going to be a week without, so go there, purge transaction logs, so avoid that problem. So thin provisioning is important thing to know, it's monitoring. If you read the guide, Plan and Deploy guide for thin provisioning in Windows 2012, they recommend to disable unmap because it can cause some delays on the storage. So yes, I worked with that. I'm still working with this problem. It's a dual layer problem there on the NTFS side and on the storage side. So you can disable. There is no problem to disable that. The only thing is that when you disable that feature using FSU2, is that every time you delete a file on a thin provisioning, it will not get deleted on the back end. You have to enable this, delete, go back. But that's only if you encounter problems with thin provisioning. Problems like my storage is unavailable for a couple minutes. Or 22 minutes, my last case. Well, at least was not Exchange, because I do get other calls when things are not working properly, which are fun. Tier storage. Tier storage movements of blocks. Very, very terrible for exchanges. I don't like it. But if you try to do it, don't use JetStress. That's the only thing I can tell. Don't use JetStress. JetStress will fail miserably because it does not have any idea of tiering. Because you say, I'm going to use 900 gig database. It's going to create 900 gig database. But if you're doing tier storage, your faster disks only are 400 gigs, and the other remaining is slow storage. Guess what? You're going to create 900 gigs, 400 on a fast spindle, and the remaining on the slow spindle. But it gets worse. When you're doing reads and writes, all those new I/O, they're going to the slow disks because the fast disks are totally full. I cannot. So bad idea. Low gen, in this case, if you must do it, use low gen. then add at least 2 more months or more to your project because you want to validate that. But that's good because we get paid by hour, right? So that's good. I don't know. Could go. Hang IOs. Hang IOs took too long to complete. On Exchange, you're going to see 507, 508, 509s, 510s. Those are the ESE events. Took too long to complete. 60 seconds or more. High latency spikes. Just make sure that it's not constant. If you see one in a lifetime and you don't get any support calls, okay. But if you keep getting those, yeah, go ahead and start getting all the support guys because something is going to happen very fast. So when storage goes down or is misbehaving, that goes down is easy because it went down and then we just take action right away. But when it's misbehaving, Exchange has those detections for storage failures. So Exchange 2010, 240 seconds, we go into blue screen the box. Have you seen the blue screen the box? F4 on 2010 or EF on 2013, right? So anything, pam, boom, blue screen. It's good, we cover. We do have DAGs, plenty of DAGs, right? Plenty of DAG nodes, so that won't be a problem. It just freaks the customer out. Just, oh, my Exchange is blue screening every day. Yeah, it's trying to tell you something, right? It's trying to tell you that, yeah. So just make sure that we investigate that. Bus reset 129, classic. It's going to blue screen every time he sees that. It's going to just. So let's talk about store port logging. So we might, but that's fine. So when I want to know where my latency from this is coming from, is it really coming from hardware or not? So store port logging is the best thing to do. Store port logging is just event tracing from the storeport.sys drive. So you just enable a performance monitor there. Let's go there. And you just try to reproduce the problem because it does create a lot of logs to do that as well. If you suspect on a latency period like 200 milliseconds or above, you can create a filter. Just log the packets that took 200 milliseconds or more. So at least you don't create a large file. What is it here? So you just open Performance Monitor, Event Trace Sessions, Starport, and then here you have to select the providers. You're going to see that there are a lot of providers here on Windows. Windows does a really, 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 really good job. Right? If there is one book that you want to read, if you want interest in that, is Windows Event Tracing Debugging. Very, very nice. I can, if you send me an email, I can send the author. Very, very good. So you go scroll down, and we should see Microsoft Windows Starport. You just click OK. And here the key thing is on the keywords, you have to edit and select IO perf notification. Select that. Make sure the other one is selected as well. And on the slides, I would recommend you to download the slides. On the notes, I have lots of blogs where I get that. Right? Because if you want to create a filter, the filter is a really massive thing to create, the Starport filter. Because first you need to convert to hexadecimal, and it's a little Indian, and then, so it gets, so here I just create without filter, so it's going to get every single IO from top to bottom. You just click next, and you're done. And it's going to create, and you can start. Quirkiness about this, every time you stop, you have to recreate. You cannot start again. Well, you can, but the data is going to be not good. So every time you have to use, you create a brand new one. And it creates an ETL file when it's done. Okay, how do I read the ETL file? So that's the $2 million question, right? You have to have XPerf, and by doing that, you can convert to a CSV file. So then after you get the CSV file, it's fine. So we just do XPerf, import, instance, store port, ETL, output, store, CSV. XPerf is a tool that you have to download, right? But it's publicly available. So once you get that, I already filtered that. So it creates a lot of fields. So I just put the fields that I want, which is the target with disk 1. And here's what I'm looking for, the request duration. So 549 milliseconds for a read command. So it's every single I/O. So, and that 549 is all the time is spent outside the windows, outside store port. Because when I'm doing that, I'm just getting everything that's out, all the time that's spent out of store port. So it actually, and the command here is in decimal, but you have to convert to hexa. So 40 is a read, is 2A. If you open scsi.h, actually 28, sorry about that, right is 2A. So you have to convert that, and 28 decimal. On the slides, I put a link where I have an ATL file for store port, ATL file for XPerf, and the scsi.h file. Sometimes it's hard to define. It all comes on the Windows support tools. And let's, since I'm running out of time, I will going to show you the XPerf. So we look at the store port's fine, and I want to see if there's something on the Windows side, right? So XPerf is your tool. To capture XPerf, you can use the GUI, which is called the XPerf recorder. Yes. Yes. Actually, the initiator and then this. So it's going to tell you how long it waited outside that. But yeah, so if I have a SCSI target that is presented, yes, you can use that too. It's a little bit trickier because we also need to see ND's timeouts, which is not easy to do. SSDs are a problem because not every SSD use SCSI port, you use ATA. If you use ATA or I, it's not going to work. It's going to be 0. So you just start through disk file IO, you create a file, and you open here. You have lots of, here I'm only interested about disk utilization. The good point about XPerf on disk, we have two main counters here, disk service time and I/O time. The I/O time is the time that the I/O took on all the way, from the application way back. Application, storage, and back. So it's the request package, lifetime. And the disk service time is the physical disk counter, kind of the physical disk counter. So never, even though you have XPerf, store ports is still the best way, because the store port is actually below the disk service time. But here you also can have an idea, because you have here this read I/O that took 12.34, and that 12.34, 964 hours is spent on the disk layer. So kind of have an idea where most of the latency comes from. And there are different types, right? So here's the size. So, and XPerf gives you a ton of information. It's a tool that if you do troubleshooting, deep level troubleshooting, you have to have it. Not only for disk, but for processes, hangs. So I got a really good one when I have a thread that was hang, but it's trying to go to another processor. That processor was on different C state. It took a long time to the C state to go up. So you just, C state. And you can upgrade the BIOS or disable C state. So XPerf is perfect for that. But for us, when we don't detect anything on store port, you can do a XPerf with disk file I/O, where it tells you from where to where, and you see if there is an antivirus or a mini filter driver that is taking up the time, right? Sorry, it took a little bit longer than I expected. Now we talk about store port logging. Disk events to watch. It's a very important one. 153 is the same as an I/O took too long on Exchange. So if you see 153 disk, it's a I/O delay. Talk to your hardware vendor. It is hardware. 129, hardware, right? Kind of did that. Here I explain the high disk service times, what to do. Enable store port. If it is a DAS, maybe more spindles will help. IOPS above expectations. So we need to know what we expect on IOPS to. Or a failed component, a controller, a cabling. If it is a SAN, collect store port. SAN, you don't troubleshoot latency on SAN without store port. Store port, I have a latency, it's a SAN, go collect the store port. And then you see what's going on. Don't waste your time. You can get the event viewer and see if there is 153s there, which will help. Much more difficult to do, because if you have too much load, this load could be from other hosts. Do we have enough ports on the storage processor? My fabric, how is my IOPS? HBA, iSCSI, we can pause the frame on switches, flow control, jumbo frames. All those things will influence that. Caching policy, all those. And when the storage is not to blame, then we go for the EasyQ, antivirus backup, which has the normal drivers. Do you know how to look for the drivers on Windows? I think it's this. If I switch it's faster. If you run FLTMC on Windows, it lists all the mini filter drivers that are installed on that box. And then you can start from there. Okay, I have a store port, it's clean, but I still have high latency. Mini filter drivers. Update those or disable those. Antivirus exclusions, backups, all those. All right? Thank you very much. Do download. I have a bunch more stuff on the slides after the Q&A. and links. And there is a OneDrive link that I have some of the examples that I can share with you, so you can just download. Yes, go ahead.
I just have a quick comment
Sure.
about when you were covering the exchange events where you got the 507 through the 510s.
Yes.
We had that in our environment with a SAN back behind.
Mm-hmm.
The SAN was dedicated to our environment. We owned it. And it definitely wasn't the SAN disk. And through a lot of troubleshooting and a lot of hardware and software vendor finger pointing and everything, we actually came to the conclusion that the HBAs were at fault.
Yes.
And they had just simply, they were working fine, but occasionally they just would stop working
They
fine.
stop, or could be the either this queue length or the flushing queues on HBAs do that. So from what we learned today, when you have that, because ESC is on the application level, right? So it's telling you, it took 60 seconds to complete this I/O, but we don't know what's in which stack it took the longer. So go to the middle, run store port for a couple minutes with a threshold of 300 milliseconds or 500 milliseconds. So you're going to see all the high spikes. If you see high spikes on store port, it means that it's below store port. The next thing below store port is the HBA.
Right.
So
yeah, and we went through that with Microsoft support cases and SAN vendor.
So then I see that it is there is something below the store port. Good. Go to the SAN, and what I would do in the SAN, give me the high water mark. There are some vendors, I don't know what storage you have, but some new storage on the monitoring side, they have high water marks saying what is the longest I/O that my store port collected from the store port, from my storage controller down. So it's from the storage in the storage, right? So it's when you get into the storage and out of the storage. So you see if there is high latency there. If they don't find any high latency there, so it's not the storage, it's not in something in the middle. So you cut back, so go to the HBA, replace HBA, see if there is a firmware, right? Because those are with the store port, you discover that it is the hardware layer or not. When you see, yes, it is the hardware layer. So we have a lot of things on the hardware layer, mainly with shared storage. Then go straight to the storage, which then you want to see if the latency is there. So if there is mechanisms on the storage controller to measure the highest peak I/O, because they will not do some like the store port for every single I/O, but they will flag the longest running I/O. So it can give you an idea if that SAN is having problems sometimes with an I/O or another. If it is not, if you confirm that, and also make sure when they are looking at intervals for latency on the SAN, what's the real interval? Are they measuring the last 20 minutes? What's the sample interval? Because most of the time, well, the SAN is okay, here's 15 milliseconds for everything. But everything is a lot, so it skews a lot of data. Store port, we're looking for that single particular I/O that took a long time. And that's what the store port is, and that's what the ESC event is. It's a single particular I/O that took a long time to complete. It actually completed successfully, nothing happened, but it's just warning you, look, this 32K took more than 60 seconds to complete. There's something wrong. 32K is not something very big, right? So, and that's the troubleshooting mechanism. Otherwise, we can stay weeks, weeks to find what's wrong, and then months if it's an HBA update to actually get the HBA fixed.
It took months.
Yeah, I know. I've been there. I have cases on my bin that they are that old sometimes. Thank you. Any more questions? All right. Thank you.